Welcome to 4.1, page number 257, the distributive property and algebraic expressions. What we're going to do is, to me, it's pretty much review. We've done enough of these that are very similar that not going to really have too much of a problem with this lesson. The distributive property, if you remember, means we take the number outside the parentheses and multiply it by each term inside the parentheses. Each term is each number or letter separated by a plus or minus sign. So when we multiply 5 times x, we get 5x, and 5 times 3 is 15. Again, 5 times 3, we know what that is. It's 15, so we can write the number here. We don't know what x is. They haven't told us what x is. It could be 3, it could be 6, it could be 12. We don't know. But until we know, we just have to put the 5 and the x together to signify that whatever x is, we're going to multiply it times 5. So that's the distributive property. So we're going to be just continuing on with that. If we have negative 4 times 3x plus 5, distributive property says again, times each term in the parenthesis. Negative 4 times 3x is negative 12x. Remember, multiplication. If you have an odd number of negatives, you're going to get a negative for an answer. So a negative times a positive is a negative. We put our x, just tag it on there since we don't know what it is. And with our negative 4 times our 5, negative 4 times 5, a negative times a positive again is a negative. And we're going to get negative 20. Okay, that is the way that you have been writing it. Nothing wrong with it. It's not incorrect at all, but a better way of writing it is if you have a negative and a positive close by like that with nothing in between them, we're just going to write it as minus 20. Because if you remember, when you had minus 20, you could change it to plus and negative 20. So we're just taking the plus and negative 20 and getting rid of one of the symbols just to keep the clutter down, and we're going to write it as a minus 20. So that's the reason for that. Alright, so let's get into doing a few with fractions. 1/3 times 3x minus 12. Okay, we're going to distribute that 1/3 amongst both of these terms here. So we have 1/3 times 3. Remember, the 3 is the same as 3 over 1, so we multiply our numerators, multiply our denominators. Do the same here. That's over 1. 1 times 12 is 12. 3 times 1 is 3. 3 over 3 is 1x, so we don't even have to put a 1 there because it's assumed that there is 1x there. 12 over 3 reduces to 4, and that ends up being our simplified answer. Alright, so continuing along on page 258, similar terms. Similar terms are terms, if you remember, terms are numbers, letters, mixed numbers and letters separated by a plus or a minus sign. Well, what we're going to do is we're going to talk about how we can put those terms together. And there's a couple rules here as far as doing that. And the rule is you can only combine like terms or similar terms. See, this thing here has a 5 and an x in it. So we've got a number times a letter, and that letter happens to be x. Here we have a 3 times an x, so a number times a letter, in this case it's an x. As long as the letters are the same, in this case, I mean, we'll be adding to these rules later when we need to, but for what you need right now, if the letters are the same, and that's basically it, then you can combine those terms. So 5x's plus 3x's, or 5 times x plus 3 times x is going to be 8x. All we're going to do is add the numbers. Do not add the letters together and get x squared or multiply the letters or do whatever. Now we look at our negative 2, and remember, always look at the sign. The sign has to go with it. So negative 2 plus 7. Negative 2 plus 7, you've got different signs. So you take the difference between the two and put the sign of the largest on the answer. You get 8x plus 5 for an answer there. Alright, let's continue on. 259. 3 times 4x plus 5. And then we're going to add a 6 to that. So we're going to do it the same way. Distributive property. And we get 12x plus 15 plus 6. We have like terms here. There's no letter with the 15 or the 6, so we can combine those. The 12, sorry, all by himself. 15 and 6 is 21, and we're done there. Alright, so let's look at one with some multiple distribution. 2 times 3x plus 1, and let's add 4 times 2x minus 5. When we do that, we get 6x plus 2 plus 8x minus 20. And we combine those like terms. Now, sometimes it's easier to put the like terms together, rewrite it, and change it to 6x plus 8x plus 2 minus 20. And then your like terms are together. If you want to do that, that's great, but notice you've got to take along the sign in front of the number with it. So I moved this 8x over with the 6x, but I had to take the number or the sign in front of it. Okay? That has to be the case. If you don't want to do it that way, another option is to put a box around the number and its sign, the box around the other number and its sign that's like, maybe a circle around this one and a circle around this one. So then you combine what's in the boxes, and then you combine what's in the circles, and you're good to go at that point. Okay, so moving along here. There will be some where they give you an equation and they ask you to solve it and they tell you what the number is. So for example, if I have 3x plus 5 and they tell me that x is a 2, okay, I will, and please get used to doing this always, get yourself into a habit of doing this. It will save you some grief later on. Putting whatever x represents in parentheses. Okay, and then that gives me 6 plus 5, which is 11. Why do I put those in parentheses? Okay, if I don't, then I have 2 plus 5, or I could put 3 times 2, and that works. But what happens is if my x were negative 2, then some people will do this, 3 minus 2, and that will give them 1 plus 5, which is 6, which is not the answer. So if you keep everything that x represents in a parenthesis, then you're gonna be right on. Okay? So something to consider as you're doing these. So throughout these problems they will say, do this problem, x equals 4, or whatever, and then you just plug that 4 in and come up with the answer using your PEMDAS. Page 261, we're going to do just real quickly, just look at a few definitions here. First one is complementary angles. A complementary angle, getting a little bit of geometry, are, well, we've got two angles that if they add up to be 90, 90 is called a right angle. If there's two angles that add up to be 90, they're complements of each other. That means that if I ask what the complement of 60 is, you'll say, well, it's the other angle that adds up to be 90. So 30 is a complement of 60, 60 is a complement of 30. Okay? So two angles add up to 90 degrees are complements of each other. If we have 180 degrees, which is what a straight line is, all the way around here measures 180 degrees. If we have two angles that add up to be 180 degrees, they are supplements of each other. So if this is 30, then this other angle to add up to 180 is going to be 150 degrees. So it's a supplement of the 30, and the 30 is supplementary to 150. So just some definitions there. If you look on page 260, there are some further definitions there to get you started. But that is lesson 4.1.